Welcome to HB Tuner's Ford Gen 2 Coyote Training Part 12. This training module we're going to be exploring programming our throttle body data. Now, if we're changing our throttle body from stock to a larger than stock throttle body size, we need to express that within our throttle body programming tables. This is going to help us translate how the throttle body is opening and moving. This is going to allow the torque control to understand how to work within opening our throttle plate properly, and it's also going to be working back into our airflow modeling. So it's important that we get this right. This is one of the things that can completely throw off the calibration for engine control modules. So if we are changing this from stock to a larger than stock size, there's a whole bunch of things to update and to change. We're gonna go over those changes that we need to make in this tutorial. Without further wait, let's jump in so we can check this out. Okay, so let's get started. We're gonna be taking a look at programming our throttle body data into our Gen 2 Ford Coyote applications. Our throttle body data is critically important to make sure that our torque modeling is correct. So translating our requested torque in our Gen 2 engine control module to a certain throttle plate opening relies on the throttle body data being correct. Also, our speed density calculation with something called our calculated map needs to be calculated from our throttle body data. So speed density hinges upon throttle body data being correct. Also, then looking at something like our torque modeling that also hinges upon having our throttle body data correct. So this is the equivalent of putting in the correct injector data. We know that's super important to make sure that our air and fuel modeling stay intact properly and all that mathematical modeling is going to be tracking properly. Same idea here with our throttle body data. So let's move in. Let's take a look at a few things here in terms of our programming for our throttle body data so we know what we're looking at and why it's important. I'm going to go up here to File, Open, and then in here, I'm going to grab a calibration file so we can open it up and follow along for the tutorial. Now, any of our calibration files here will work from 2015, 16, or 17 Mustang. If you have a calibration file from your vehicle that you've read out, you can also follow along with that particular calibration file. Okay, I'm going to go into a 2016 Mustang folder here and just grab a 2016 Mustang GT and click Open. Doesn't matter which file, again, that you're working with. Now, from here, we're going to go into our Engine tab, and we're going to go from our General right here over to Airflow. And from Airflow, we're going to land here on our Electric Throttle tab. This is our throttle body data information. So this is everything related to our throttle control, whether it's a pedal or a plate. Now, we're talking about the plate, which is the drive-by-wire throttle body assembly that's bolted to the intake manifold. The pedal assembly is what you put your foot on in the car. They are separate from each other, but they're connected virtually within the programming. So we give a certain amount of pedal input that goes into our torque model, and then we can figure out how much the throttle plate needs to be open based on knowing the airflow and a couple other conditions and parameters. Now, we're going to get into that in other training modules, so I don't want to get weighed down on how all that fits together, but this is where we program the actual throttle control. Now, out of all the tables we find here and a lot of parameters to work with and to change, we're more interested right now in the predicted throttle angle and effective area. These two tables are inverses of each other, and these are responsible for essentially 98, 99% of our throttle control in terms of our throttle body modeling. Now let's go ahead and open up both of these tables here. So I'm going to go pop this one open, pop open the effective area. Let's close this out, and let's take a look at these tables overlaid on top of each other. Now, the way this is going to work, if we're taking a look at the ETC predicted throttle angle versus effective area versus our VAC, there's the ETC vacuum. This is how much vacuum the engine is pulling at any given time. And then we're going to find we have our effective area. That's essentially translating our surface area for the throttle plate that we're dealing with. Different throttle bodies will have different effective areas. That makes sense because the throttle plate size is going to be different. Now, looking at this, the effective area, ETC vacuum, depending on where we're at, this will have a throttle angle amount. This is essentially telling the engine control module at a certain amount of effective area, at a certain amount of ETC vacuum, we should have the throttle body here at approximately 20.5% throttle plate opening. Now, we also have down here ETC effective area versus throttle angle versus vacuum. This table is looking up that specific throttle plate opening, in this case 20.5. We find that right here at 20.5. And in the column here, it's expecting to see a surface area or effective area here of approximately 0.53 inches squared. So these are a direct inverse each other. They need to match up and be a direct inverse. If they're not, that can lead to torque modeling errors, specifically high wheel torque errors, which can put us into throttle shutdown conditions if we're driving and our wheel torque errors get too high. We don't want to do that. We want to make sure that our wheel torque errors are minimal and reasonable so that we still have the drive-by-wire fail-safe that can be in place that can shut our throttle plate down in case something goes wrong, like a runaway throttle, which is why that system is there. So these are essential for making sure that our engine control module understands our torque modeling and our throttle relationship. We'll get into this a little bit more heavily when we look at the torque specific tutorial. So the torque tuning tutorial, we'll break things down and we'll come back to these tables a little bit. But these tables have to be inverse of each other. They have to be right. Now, we don't want to make up the data. We want to make sure we're using data that is valid and that we have copies of. Now, typically, my experience with a Gen 2 Coyote, naturally aspirated, going to a larger throttle body, very minimal, if any, gains on a naturally aspirated engine, unless you're putting in cams. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.